From the Youth Science Council, this is Good Question, a podcast about science in the UAE. I'm your host, Sara Shirbaji. Today, we speak to Noora Al Saeed. Noora is an astrophysics and planetary sciences PhD candidate at the University of Colorado Boulder. We talked about the Martian atmosphere, the surface on Mars, the relationship between Mars and Earth, and quantum computing, amongst other things. Here is our conversation. Welcome to the show, Noora.
Thank you.
Good to have you here.
It's good to be here. Thank you for having me.
All right, so let's start by talking about where you currently are and what you're currently doing.
Right now, I'm a PhD student at the University of Colorado in Boulder, and I study Mars, or specifically, I study the water cycle on Mars and how it has evolved over the years. So that's where I'm at right now, and I can't think about anything else because as a student, that's all you focus on.
And you are taking classes simultaneously?
Yeah, I actually just finished all the credit requirements. So I finished all my classes, and right now all I'm doing is just pure research.
For the year or for the entire duration of your PhD experience?
So the first 2 years were mostly classes and a little bit of research on the side. And right now I just shifted into mostly research and classes on the side. So it's going to be the majority of my time being spent on just doing research.
Okay. So can you give us an outline about your research?
Yeah. So a paper that I just published, alhamdulillah, that I've been working on is titled The Evolution of the Martian Water Budget from 3 billion years ago to the present, which sounds like a lot to unpack, but simply what I do is I created this model, computer simulation, to see what are the inputs and outputs of how the water behaves that will affect it over the billion-year timescale. So stuff like volcanic outgassing and eruptions, how they add water into the system, atmospheric stripping from the upper atmosphere, so how water is removed when the solar rays hit the top of the atmosphere and strip away some of the water molecules or hydrogen and oxygen, and seeing how those major systems that affect the water balance out over large timescales. So the point and the addition of my project to the scientific community is providing sort of parameter space how the water would have evolved and how much it has changed over time. So how much water there is now, how much water there was in the past, and how that has fluctuated over time.
So there's water now on Mars.
Yeah, so there is water on Mars, but it's not water in the way that you think. It's not liquid. The water on Mars right now is locked up as ice in the polar caps mostly, and the rest of the water is locked up as ice underneath the surface, so beneath the layers of dust in the lower latitudes. And there's a tiny bit of water in the atmosphere, so it's only in gas and ice form. The majority of it, at least.
What does locked up mean?
So locked up means that it can't be added back to the atmospheric system. So it's just permanently under the ground. It's called permafrost. So it's permanently under the ground. It's not being exposed to the elements or anything like that.
Right. And do we know how that occurred?
So we presume that this was remnant water from 4 billion years ago or 3.8, 3.9 billion years ago. On Mars, we believe, and most studies point in this direction, that there was a lot more water and it was liquid on the surface. And the reason why we believe that is because there's signs on the surface of Mars, if you look at the imaging from the satellites, of river valleys and channels and lake beds that have dried up, but you can see the carving of those features that are caused by water and some materials that would have only formed in the presence of water that we see on Mars today. So that's the inference that we made, that there was water in the past, it was liquid on the surface, and so there must have been more of it, and it was flowing freely as liquid on the surface.
Do you have any idea about what happened so that it no longer is present today on Mars?
Oh man, I wish I knew the answer to that. I'd be published in Science right now. So it's not as straightforward as saying like this thing definitely happened and that's why it shifted. But It's a combination of a bunch of different factors. So the fact that Mars is smaller than Earth, it's an eighth of its size or a third of its gravity of Earth. And so that means that it won't hold on to the atmosphere as effectively as Earth would. And so it has a smaller atmosphere. Right now, today, the atmosphere of Mars compared to Earth is like 0.6 millibars, whereas Earth is 1 bar. So it's significantly smaller.
What does that mean?
In terms of pressure. So if you stand here, you're experiencing, like at the surface of Earth, 1 bar of pressure on top of you. So that's telling you how much atmosphere there is above you. And if you're standing on the surface of Mars, you'll be experiencing 6/1000th of the atmosphere above you. So it's much, much, much less, thousands of times less than it is on Earth. To compare, it's like standing up where the stratosphere of Earth is. There's like not a lot of air around you, so it'd be hard to breathe in anything. But even if you could breathe in, it's not stuff that you would be able to breathe on Mars because it's mostly CO2. 90%, 95% of the atmosphere is carbon dioxide. So you wouldn't want to breathe that. It's toxic.
And what sort of consequences does that have?
On the human body?
Not particularly on the human body, on the atmosphere in Mars. So what makes it so distinct from Earth? Like, so we know that because of the pressure differences and because of the atmosphere differences. And what does that translate to in terms of consequences?
Okay. Well, the compositional difference means that, first of all, the Martian system is a bit simpler to study in that it doesn't have as many complex parts of it. So life on Earth and the biosphere has such a big, diverse effect on the atmosphere itself, as well as like the amount of water and how much we have of everything. It makes the system way more complex. Whereas on Mars, because it's 95% CO2 and then constituents of other molecules, then it's not as complicated to study. So it makes it simpler to study. But that also means that the atmosphere itself is run by different chemical processes. So they're not going to be the same on Earth. So it's kind of an interesting little fun game that you get to play like in a completely different environment.
Yeah.
Yeah.
And that probably is the reason why Mars doesn't accommodate the kind of life on Earth, the kind of life that exists on Earth.
Yeah, yeah.
Because of its... And so the surface of Mars then is probably impacted by that too. I read that there are differences between the two hemispheres of Mars. Can you explain that and tell us why there are differences and what the surface is like on Mars?
Yeah, so they call that the Martian dichotomy on this surface because the northern hemisphere is at a lower elevation compared to the southern hemisphere. And so they call them the Southern Highlands sometimes. But the reason for that as to why it became that way, there's a bunch of hypotheses. The one that is usually invoked when it comes to anything in space is always like a giant impact that must have stripped away a bunch of
It's like the go-to hypothesis.
Yeah, why is Venus, turning on its side or
Meteor.
like upside down? It's giant impact. It's our favorite thing to throw around. So that's one hypothesis. Another is just simulations that have been done about like the internal geophysical processes within Mars and the way that the volcanism has occurred made it shift where the balance is. It's way more complex than I understand. But yeah.
Volcanism? So there were volcanoes previously?
I wouldn't say I don't think we've visibly seen any volcanic activity since we've been observing Mars. But the largest volcano in our solar system is on Mars.
In terms of the structure, structure of a volcano?
It's really, really big. It's like the size of, I think, Texas, I want to say, but I'm not sure. But it's because it's such a volcanic planet. So the entirety of the Martian surface is mostly basalt, which is rock that is produced via volcanic processes. So it's like when lava flow occurs, it deposits basalt. And that's the majority of the Martian surface. And one of the largest volcanic systems is the Tharsis volcanic system. And Olympus Mons is the largest volcano within that system, and it's just so one of the largest mountains too in our solar system, that the steepness of it is not that steep because it extends so long that you're essentially climbing it would be just walking slightly uphill for a really long time.
Yeah.
Yeah.
So I guess it's almost like a relic of a volcano, and that's how we make these inferences that so and so existed on Mars. It's because we see all of these sort of structures, and we make these inferences that there must have been volcanic activity, there must have been water, there must have been so on and so forth. Is that true?
Yeah.
Okay.
I view it as a fun little try to build a story by what you see at the end. So you have the conclusions of the story.
And then you speculate as to what caused these consequences that we observe today.
Exactly, yeah. I always tell my friends that my job is a storyteller, but there's so many stories you can tell and have the same conclusions.
So that makes me think, because we're so anthropocentric that do you think there's a possibility that we're kind of just imposing our expectations and our knowledge and our just what we know about Earth on Mars? So we're kind of seeing Earth on Mars when we talk about volcano and water. And do you think there's a degree by which we are kind of imposing our earthly expectations and our human expectations on other planets so as to project what our experience is on Earth? And we were looking at the solar system and we were like, oh, well, this must have been like Earth that many million years ago. And I'm just wondering.
Yeah, I mean, that's something that's a little bit inescapable because we are human and we live on Earth. And so there's always going to be some form of bias. But the nice thing about science is that it's facts at the end of the day. And it's the basic laws of physics are not going to change. Just because we experience them differently. So whatever is happening on Mars, the way we study it...
I thought that was a point of theory of relativity, that we do experience them differently, and that's what causes changes.
Yeah. But essentially, the basic laws are not going to change. So the inferences that you're going to make are going to, if you base them on, what is what we've studied in science in terms of the laws of physics and the laws of how atmospheres work, regardless of what planet it is on. Hopefully you'll get to the conclusions that are unbiased. I see this happening more so in when it comes to hypotheses of life on Mars. So whether or not there is life there, or when we see a system, an observable that we find on Mars, we immediately want to jump to the conclusion that it's caused by life, when really, just the storytelling, the conclusion could be caused by several other things, not necessarily life, but we always want to test that one first. So in that way, there is a bias in that we always test the hypotheses that are closer to home first, which makes sense because those are the ones we know best, and so we can rule them out more easily. And then we can test the ones that are more
abstract, I guess.
Compared to what we know. Yeah.
I mean, I guess that's science is motivated by questions that we ask, and the questions that we ask are designed by us. So what questions do we investigate and what questions we don't investigate ultimately that's the product that is science.
Yeah.
And so that is definitely dependent on our questions and the formulation of our questions. And that is dependent on our motivations.
Yeah.
So what we're interested in at any point in time.
Yeah.
Right. And so that kind of leads me to the question of, how accurate is the representation of Mars in movies? And so that's the first question. Can you let me know?
So I'm trying to not be bogged down by the physics in movies so that I can actually enjoy them and not turn into just someone who's always picking out what's happening that's wrong in the physics.
You don't want to be that guy in the middle of the cinema.
Exactly. Yeah. I'm trying my best to not do that. So the first time I watch it, I usually don't focus on these things. But more recently, they've been really good at depicting, just what we know about Mars and what we know about space in general in movies. I think that's due to the fact that there are a lot of scientists who watch these movies and then they nitpick and then
they email their feedback.
Yeah, they email their feedback. So they started hiring more and more of consultants for movies and any depictions of space. I think the one that a lot of people would mention is The Martian.
Yeah.
They got 99% of the depiction,
The science
right.
Cool.
And then the only thing they got wrong was the major plot driver of that movie, which is the big storm that happens at the beginning.
Oh.
Because, as I mentioned earlier, the
Yeah.
atmosphere of Mars is so thin
Yeah.
and there's not a lot of it that
Yeah.
winds are not going to be knocking down like giant, spacecraft in that way. It's
So
not
they
going to
have
be as catastrophic.
like a much more minor impact on objects they kind of come to contact with.
Yeah, because the atmosphere is thin, there's less of it to be like knocking things around, so it's not going to be as intense.
Yeah. God, we're so space centric nowadays in terms of our like movies and our entertainment. It's almost like there's always it's always like a movie that starts with a catastrophe. You know, somebody goes on space and then it's a big catastrophe, and then so starts the plot of the movie.
Yeah.
So the second part of my question was, what places on Earth resemble Mars that you know?
So it depends on which aspect of Mars you're trying to resemble, because if it's just visuals, Wadi Rum in Jordan, that's a really, like, that's where they filmed, I think, a good chunk of The Martian, and that's where they film a lot of, like, Martian-related stuff. I mean, the deserts in the UAE here are also, just the vast sand dunes, like fields of sand dunes that are endless. That's kind of what you would find on Mars, even though the sand itself would be different. But when it comes to composition, so I've been on 3 or 4 geology field trips in the States where they take us out to planetary analog places, like places that have planetary analogs, where we can, do similar tests that we would do if we were to send geologists to Mars or geologists to the moon and all that. And so it's anywhere where there's volcanism, exposing or like bringing new rock from Earth's interior back onto the surface. So Hawaii is a really good place, which I've been to, where we did a lot of, Mars analog studies to determine, the composition, how impacts affect basaltic material and all that. Iceland is a good one as well. I believe in Greenland there are some places too. There's a bunch more.
So it's kind of like a simulation of some sort. Like it's like the volcanoes here produce the kinds of sort of components that you would potentially learn about in Mars, or at least are in some way like it's a simulation of what goes on in Mars. Is that what that's why it's called the analog? You're saying it's an analog?
Yeah, it's an analog in the sense that those are the kinds of rocks you would see.
Yeah,
because they're
are they
formed
identical?
by the same processes.
Like they're identical, or they're similar? They're just
similar.
Very similar.
They're more similar than to say like you go out to the desert here and pick up a rock, because the rocks here, or a lot of rocks, are eroded by water here, whereas on Mars they're mostly eroded by wind and other processes. So you want somewhere where like the rock has just freshly been exposed, and then you can analyze it and see. And mostly the composition is going to be similar to that of Mars. But there's definitely going to be differences because we have so many other factors affecting the geology here on Earth. Yeah. But you take those into account and you still perform the analyses and make comparisons.
One of the properties I want to mention was compound methane. I know it's generated by living creatures, but we know there's methane on Mars. So how did that happen?
So this is a recent in terms of like in the past couple of years, article that they were measuring methane cycles on Mars and seeing that there's a peak due to different seasons, and so immediately they were like, could this be life? And the conclusion is that we don't have one answer, and life is probably not the answer. But that's, it became a thing that people were talking about because they were like, well, methane is a sign of life, or it's a byproduct of life. And so if we see methane in such quantities that are dependent on the season as well, could that mean that there's life on Mars? But the system on Mars allows many different ways for that cycle to act the way it is, that are non-biogenic and not life-dependent. That you can't immediately say that it's definitely life that caused it. So it's more complex than to just say, oh, we breathe oxygen and we give off, these different molecules, therefore other life on other planets are going to do the exact same thing. Or if we see signatures of the same mechanisms, that means that there's life. It's not a direct, definite hypothesis that you can throw out there.
So I wonder then, because it seems to me like a lot of these questions, like you say, there's this nagging, just speculation on our behalf of, is this generated by life? Does this lead to life? Is it inhabitable? Is it, is it just because these are the questions that are, I guess, relevant to us? That, as in the readers, the general population, that these are the questions that are discussed, or is this indeed a driving motivation for scientists? Because I feel like maybe it's because, like, for example, in psychology, right, there's more abstract technical things about like studying visual perception and stuff like that are very technical, very detailed, very precise.
Yeah.
That nobody cares about.
Yeah.
And, you see psychology today doesn't tell you about your, cognitive capacities in that way, in a very, very specific way, and how you interact with the world in terms of your sort of perception, in terms of your, how, your senses and so on and forth. But, so it's not something an article you probably read. So the stuff that you read about like relationships, about positive psychology, about that. So that tends to populate the media.
Yeah.
But that's not a fair representation of psychology, because psychology is very vast and there's a lot to talk about within psychology that's pretty detailed and the general population might not be interested in.
Yeah.
So comparable, like I was wondering, compared to that, do you think then that like the questions that are motivating the scientists, are they similar to the ones that we're asking the population and as a general population? Like, is it just that it's relevant to us that we're asking all the sort of, in the media, we're asking all the questions that relate to human life and,
Yeah, no, that definitely, a similar system sort of exists. I mean, it happens in all of the sciences, but it definitely exists in astronomy and geology in the field of planetary science, in that the questions that the general public is most interested in is really just a percentage of the work that's being done in these fields.
Yeah.
And it's what gets to the top, what gets media attention.
Yeah.
But
Yeah,
there
that's what I
are
suspected.
plenty of scientists working on questions that, you wouldn't necessarily, as someone in the general public, you wouldn't necessarily be interested in. In answering, I guess, or not enough that you would, go off and like do an entire 3 years of your life dedicated to just studying that one topic. But that's the nice thing about science, in that it's not motivated by the market or by just
the consumer, the consumer of the science.
Exactly, it's motivated by people's
the producer.
own passion.
Yeah.
And people are passionate about all sorts of things, like, and I'm passionate about all science regardless of what it is. I just happen to be focusing on Mars right now, and my friends are studying cosmology and the cosmos and galactic nuclei and all that. And there's nothing that you would find there that's related to our own, human life in any way. We're just trying to answer questions. Most of the time, if you ask a scientist why they're doing, it's because they just want to know. And they'd always answer like, why not? Because I'm curious. And it's curiosity driven rather than what am I going to get out of it, or is this going to be relevant to life on Earth or anything like that? It's just a curiosity thing. Yeah.
That's interesting, because so I'm, this, I'm very interested in philosophy, and we always get the question of, is it practical? What's the point? Why do you do it? You guys always think about all these abstract things, and so we always get that question. I think there's a saying by Bertrand Russell that's very interesting. It says, "It's the things that you're curious about as a human being. If it's related to your curiosity, then it is practical. It's relevant to you, and you should care about it. You know what I mean? No matter how abstract it is, if you're thinking about it, if it motivates your curiosity, then it's relevant to you, and that's it. It's practical. Period. You know what I mean?
Yeah.
Anyway, then, okay, I've got another question about, again, Earth and Mars.
Yeah.
And so I read that life on Earth could be linked to meteorites on Mars, that life on Earth generated or originated in Mars. Is that true?
Oh, yeah. I think this is called the panspermia hypothesis. I can't remember the name exactly, but it's this idea that life originated on Mars back when Mars, had more water, more liquid water. and more a thicker atmosphere to protect it from the sun and all that. And a meteorite or a piece of rock from Mars was ejected from the system either by a giant impact or some other process and made its way to Earth, somehow protecting, that life in this journey across space to Earth, and then landed on Earth, and that's where the beginnings of life on Earth happened when it landed here 3.8 or 3.9 million years ago, and then flourished here because the environment is much more conducive to life. So that's the hypothesis, and it's a fun one to think about. I think it's a fun one to just bring up when this topic comes up in conversations. But I don't think it's one that's being taken very seriously by the scientific community because it's one of those non-falsifiable hypotheses that you can't really say that this is what happened, but you can't really say that it isn't. There's a lot of it's 3.9 billion years in the past. You can't really for sure definitely say that this is what happened. So you can always speculate and build hypotheses. So you can take that and then look at what you know about Mars and what you know about Earth. Why would it start on Mars and end up coming to Earth? Why not have it start on Earth if it's equally as likely for life to start up in those kinds of environments?
What are the odds that two planets in the same solar system were both conducive to life?
Yeah, I mean, it's really
pretty unlikely.
It's really depends on the system. So as long as you have the right
I guess maybe because it's a solar system. In this one system, maybe there are elements within this one, something about the solar system, that particular system, that has elements that are conducive to life.
Yeah.
Because I guess statistically, the likelihood of life anyway is pretty low.
Yeah.
But to find it in one solar system probably higher than to find it scattered around other systems.
Yeah.
What do you think about that?
So right now the topic of exoplanets is really hot in the astronomy community, and that's a question that they're trying to answer. So is it more likely if you have a system that's similar to our solar system, or is it more likely in other stellar systems that are have suns that are smaller than ours or have suns that are larger than ours? Which one is more conducive for life? I mean, we've kind of narrowed down what we call is a habitable zone. So based on what we know about how radiation affects life from the sun, we're okay, it has to be this distance from its host planet so that the temperatures are not too hot and not too cold. Because you want something to be moving around but not being immediately killed off by the solar rays.
Yeah.
So there's that area around its star that you can find life. And then you add in the fact that you need some sort of liquid, and the reason why liquids are so important for life is because you have to have a redox reaction. I'm not going to go into details of what you really actually need, but you just need exchange of, food is here, I got to go grab it, and you need to be able to move in that system, and liquids are the most ideal spaces for life to do that instead of air where everything's really far apart and solid where you can't move at all. So that's why we always look to water. Where water is liquid is where we would look for life, because it's the most probable place to look for life, and so on and so forth. So you add all these different things that life would thrive in or life could potentially pop up in, and you narrow it down to this little one area around the sun that for us the habitable zone. The strict one is just around Earth, and if you want to make it less strict in that you remove some of the conditions, then it's all the way from Venus to Mars. You can have a habitable zone where life could have potentially existed, and it varies from star to star.
So if we kind of move the Earth around in that region, it would still accommodate life?
It would accommodate life, but maybe not as we know it, because there are some. So if we're a little bit closer, then the temperatures would be too hot for certain life forms to thrive, but others
Including us?
would. Yeah. Maybe us in the Middle East will be fine. Yeah, I wouldn't say that because the biosphere is so fragile that humans would probably suffer in the case, like this is why
There
climate
goes
change is
the UK.
yeah, that's why climate change is such a huge problem, because even slight shifts in temperatures would completely mess up the biosphere that we rely on, and so we would at the end of the day, end up either being exterminated or really suffering in that system.
Well, it's a good thing we're here.
Yeah.
So then I'm curious to know, what's one thing that you are super interested in?
Mm-hmm.
Like, that's pretty abstract and pretty technical, and I can't relate to.
Okay, so this is actually sort of an origin story of why I started studying.
All right, let's go for it.
Yeah, I got into undergrad here at AUS in Sharjah.
I work there.
You do? Okay.
Yeah.
That's where I did my bachelor's degree in math.
Yeah.
But I originally wanted to study quantum mechanics and quantum physics.
Nice. We're teaching that now.
Really?
Yeah.
Well, I'm glad to hear it.
Yeah.
When I was a student in AUS, there was no physics degree, and I was really fighting hard for it. And then it got implemented the year I left. Yeah. So I really wanted to go into quantum computing specifically, like getting into the memory going from like 0, 1 to 0, 1, 2, 3, 4 once you use quantum bits and all that, and like it's too complicated for even me to understand. So I can't explain it very well because I don't understand it. But I was like, this is where I want to head.
Yeah.
Like this is what I want to do. And then I met Dr. Nadal. Yeah. And
Dr. Nadal Qassoum, right?
Yeah. Dr. Nadal Qassoum. He kind of saw the passion that I had for science in general and was like, would you be interested in doing something astronomy related? I'm like, yes, please sign me up. And that's where I shifted to studying astronomy. And here I am today.
So your abstract thing is quantum computing?
Yeah.
That's really cool.
Yeah.
That's very trendy right now. Not particularly quantum computing, I'm not sure about that, but generally just quantum physics. You hear a lot of people talk about it. That's another thing that's like we take and then we relate to us and then we make it kind of a big deal of, like talk about free will and determinism and so
for
on.
sure. So, superposition and all that, yeah.
Yeah, exactly. The Copenhagen interpretation of quantum mechanics is very popular. I recently read a book by Tim Maudlin. Maybe you know him. He's a philosopher of physics, but I think he's also a physicist, and possibly a cosmologist. Not sure. We'll have to check. But he wrote a book called Space and Time, and I read it, and it was very complicated. But and just kind of complement the reading, I was kind of watching interviews by him, and he talks about the Copenhagen interpretation of quantum physics, and he says that it's very popular in the media, it's very popular amongst lay people, but it's not like you walk to an academic department of physics and then meet a quantum physicist who is very big on the Copenhagen interpretation, But then we take that as one other thing. I feel like this episode is dedicated to us distorting science in a way that just makes it interesting. You know what I mean?
Yeah.
But it is interesting. It is intrinsically interesting. SubhanAllah, you still require that kind of level of expertise and technicality and like comprehension of the technicalities of science.
Yeah.
In order to motivate us to ponder these abstract questions.
Yeah.
And not just stop at the things where it's like, does this relate to me or not?
Yeah.
And so with like the quantum physics, it's like you hear about it a lot. There's a lot of like consciousness and quantum consciousness, and not just Penrose style, but like related to I don't know, like Buddhism type of animism and connectedness and stuff like that. So I've seen my fair share, and hopefully one day we'll have also quantum physics on the show to talk about this.
Yeah,
because I've seen like my fair share of extremely controversial statements made about the interpretations of quantum physics or some of the implications from the studies produced by quantum physics today.
It's a complex topic that you really, even though those who are experts in the field don't fully understand, because it's so disconnected from our reality and how we experience the world, and like everything happens on a macro level that when you get down to those sizes and how physics acts in that realm, it's so counterintuitive that it's really hard to really get a good grasp of it. And it's we use a bunch of quantum just like more of the basic parts of quantum in astrophysics. So we don't really get into the complicated details
the nitty-gritty of it.
The nitty-gritty of it. But even the parts that we use are still like so fascinating and so counterintuitive. On initial, like even the double slit experiment. I don't know if you've heard of it.
Yeah, can you explain that to us?
So in a very simple nutshell, it's light. It's an experiment to show that light photons act as a wave and a particle, the duality of photons. So they get just a piece of cardboard that you cut a slit in and allow you just one slit, and then you put another cardboard where you have two slits, and then what you do is you allow light to pass through, and when you've covered one of the slits, then you only see one dot on the other side of the screen. And if you allow both splits to be open, then you see a wave pattern. And, this shows that light is acting as both a particle and a wave simultaneously. So the light doesn't just land on the other side in two lines, just like the slits show, but instead it's like concentrated around the lines, but then there's a lesser around next to the lines and then more again. So kind of like a wave pattern that you see on the screen. And it's just, how does that happen? Initially, when you see that experiment, you're like, what is going on? This looks like sorcery. But, it's based in quantum physics, and like the laws in quantum physics are different than what we're used to. So it's, I guess, adds a sense of mysticism to science, which just makes it all the more fun and all the more exciting.
Yeah, I see what you're saying completely. Yeah, but I mean, this is exactly what I'm talking about. It's like where we've kind of exploited that mysticism so as to say, well, here, kind of like anything goes. Well, if it's counterintuitive, then any other counterintuitive thing is equally plausible. Does that make sense?
Exactly.
You know what I mean?
Yeah.
Anyway, so let's go back to the plausible science of Mars. And so so the Martian year is 687 Earth days.
Yeah.
And a Martian day, a day of Mars, lasts for about 24 hours and 37 minutes.
Yes.
Okay, so that's...
You've memorized this. I don't have this memorized, but yes.
Memorized, right? So the day of Mars, it's Mars spinning on its axis, correct? And but for the Martian year, that's Mars spinning. That's how long it takes for Mars to spin around spin around the sun.
Yeah, to orbit the sun. Yeah.
Yeah. So what causes these differences between Earth and Mars in that Mars is taking a longer time to spin around the sun?
Okay, so the Martian year being equivalent to roughly 2 Earth years, that's purely orbital mechanics. So as you go further away from the sun, the time it takes for you to orbit the sun once would be longer. So Mercury spins much faster, and then Venus a bit slower, Earth a bit slower than that, and so on and so forth. And the relationship is equivalent to 1 over the square of the distance. So it's not a linear relationship. It's squared. So
yeah, I see. Okay.
It's going to be... so the time it takes for you to orbit the sun once is going to be related to the distance you are from the sun, and it's going to be longer for Mars, and that's why it takes twice the amount that it takes Earth, for example, to orbit the sun. I think Mars is at 1.5 AU. That's astronomical units. Earth and the sun are 1 AU apart. That's the baseline that we use. It's like the metric.
Astronomical unit.
Yeah.
What does that mean?
It's equivalent to some number that I should have memorized, but it's the distance from the Earth to the sun, the average distance from the Earth to the sun.
That's how it's measured.
That's how it's measured. It's equivalent to some number in kilometers.
Okay, I'm saying, why not just kilometers? Okay.
That you could use that, but then you'd have to use that number constantly because you're always comparing it to the distance from the sun to the Earth. So we always just use 1 as the baseline and then
it's pretty efficient.
To that.
Okay, yeah.
So Mars is 1.5 AU away, which causes that difference.
Yeah.
Yeah.
All right, so what about gravity then? How does that differ from Earth?
Yeah, so Martian...
You mentioned it's 1/3.
Yeah, Martian gravity is 1/3. I got the privilege to experience 1/3 gravity a year ago. Have you heard of the 0G flights? where they like get you in an airplane and then you go up to a certain altitude and then they fly in a parabolic motion.
No.
And then you get to
What?
experience what 0G feels like or 1/3 G.
Where is that? Where'd you do that?
So this was through the Mohammed bin Rashid Space Center. They had a program where you could apply as a student, and it was in the States, in Florida. And I got so the way that the plane flies determines how much G force you feel on your human body.
Yeah.
And I got to experience what 1/3 of Earth's gravity feels like, and it's very, very confusing, but also very fun. It's like if we send humans to Mars, or if I want to be optimistic, they're gonna have a much easier time moving around. I don't know if you've seen any of the footage of humans on the moon. Yeah. So how they're like
bouncing,
skipping around.
Yeah.
It's because like one slight push, like even if you're taking just a step, that is enough pressure to like really like throw you off and like send you flying. So
nice.
it's definitely an adjustment. That's why there's this whole a lot of studies being done on how to like keep your muscles from reducing in size and like your bones from atrophying because you're not experiencing Earth gravity. Like our human bodies are made to function on Earth gravity, and as soon as you remove the human body from that system, it kind of like has to readjust and is not used to it. So there's a lot of very little details of the human body that we didn't even think about that are gonna shift and alter based on these different gravity conditions. So humans on Mars are gonna have to do a lot of
that's actually my next question. How would they live on Mars, and like would they be susceptible to different diseases? And that's kind of a pretty big yes, and that's one affecting their muscles and bones, for example.
Yeah. Muscles, the gravity is going to affect them in that, just as I explained. They're going to have to readjust to a different gravity, and so the muscles and bones are going to act differently. Your spine is going to be like more extended, so if you want to be taller, maybe go to Mars.
Yeah, and that would affect your balance as well, and your inner ear maybe, and stuff like that. Because I remember once like listening to something about this of like how astronauts, when they come back to Earth, they have to readjust in terms of their balance.
Yeah. Their inner ear is like all messed up.
Yeah. So I suppose that would be applicable also to Mars.
Yeah. It's not going to be as intense as sending astronauts to the International Space Station, because International Space Station, you're experiencing zero gravity on the human body, which is not to say that they're not experiencing the gravity of Earth.
So
they're just in free fall.
I'm curious about that. So where is the International Space Station?
It's
like I'm not expecting coordinates, but like roughly.
It's orbiting around the Earth in low Earth orbit, I think.
Okay, right.
Don't quote me on this.
Yeah, okay, that's fine.
And that's where like all the astronauts since the Apollo missions have been going to.
So why is there no gravity in that area, but there is gravity on Mars? Kind of, feels like it should be closer to the Earth, maybe?
Yeah, so that's the thing. It's this is a misconception people have about being in space. You're not experiencing no gravity. You're just experiencing gravity in a free fall sense of frame of reference. So what's really happening about when things are orbiting, so the International Space Station is orbiting the Earth. So it's kind of like if you stood on the edge or on top of like the North Pole and you threw something, it's going to eventually land on Earth. But if you threw it fast enough so that it makes a complete revolution, comes back to you without ever landing on Earth, then it's constantly falling, but the object being thrown experiences no gravity in its own frame of reference. So that's why it's called 0G, because you as the object are not experiencing the force of gravity in your own frame of reference. Well, you are, because that's why you're moving in a circle. But as astronauts in the International Space Stations, they're basically free-falling constantly. So they're not being pulled in any direction because they're in this orbit. Yeah.
Okay.
Yeah.
I have to jump to my last question, unfortunately.
That's
can't
fine.
keep going on, but I really would love to. But anyway, I'm really curious to see what you'd say about this. So
Okay.
if humans were to colonize Mars, Should they develop new interplanetary or solar system laws,
Mm.
or laws particular to Mars, or the laws existent in the colonizing country? What would you do?
Um, that's something I've actually thought about.
Really?
Yeah, I was involved in a project called Mars 2117. I don't know
Okay.
if you've heard about it,
Mm-hmm.
but it was presented in the World Government Summit
Mm-hmm.
a few years back, and it was answering like what would a Mars economy or Mars government look like. And I
Mm.
kind of like the way that kind of system we've developed for Mars 2117 looks like, in that it's kind of a conglomerate of all the different systems on Earth, at least the ones that work efficiently.
Mm.
Which how would you define what work efficiently is? It's a different answer,
Mm-mm.
a separate story there. But I like to imagine it being like sort of a unified government that takes from each of the different governments that we see here on Earth and makes it work for the environment of Mars. So it'd have to be updated for the harsh, environment of living on
Mm.
Mars. So it's the gravity,
Mm-hmm.
the atmosphere. You'd have to live in very small systems. So like the psychology over there is going to matter a lot, like how people interact with each other. So it's going to have to be catered to the environment of Mars, which is going to make it unique from any system that exists on Earth.
Mm.
But it'll take the majority of the influence from, like, the basics are going to be there, like don't kill each other, please. Be nice.
I'd like to think that's universal. Yeah.
It's mostly universal. There's like studies in anthropology where like even those are like not
Yeah, yeah.
necessarily in place, but sort of the basics would be the same, but then the details are going to vary depending on the fact that you're on Mars. So I like to imagine that it's going to be a new system that we can't even really think of the details right now until we experience it, but you can provide like a baseline.
Mm-hmm.
The same kind of baseline that you would provide to, say, people spending a long time in Antarctica when they're cut off completely from any of the any other part of the world. They can't communicate sometimes, and sometimes like you can't get out of this for another few months, especially those who spend like winter over there. So it's kind of, they've done it. They know how to coexist in that sort of environment, but most of the problems that they face are going to be based on the harsh environment and their own psychology. So creating a system that will cater to that is necessary.
I guess we'll have to consult ethnographers who study communities that exist in extremely hard conditions.
Yeah.
Or probably historians as well, to kind of look at history and how people operated back when I'm not going to say like they were, barbarians back then, but like how they operated under extremely harsh conditions, and probably form then a system of governance that would be suitable for Mars.
Yeah.
But yeah, perhaps under the very harsh conditions we will unite, and there will be a sense
And
in
we'll
which
get to that platonic ideal of government.
Exactly.
As long as it provides what it needs to provide for that community to survive, it should work.
Yeah.
Yeah.
All right. Well, Noora, it was very, very nice having a conversation with you.
Thank you
and
so much.
Really
Yeah.
appreciate all the information you shared with us today. So thank you for being on a show. We really appreciate it.
Thank you for having me. I enjoyed this very much. Thanks.
That was Noora Al Saeed, astrophysics and planetary sciences PhD candidate at the University of Colorado Boulder. To listen to more episodes, you can find Good Question on Apple Podcasts, Stitcher, Spotify, or wherever you get your podcasts. If you have any questions, comments, or suggestions for what you'd like to see from us next, you can reach us at GoodQuestionUAE on Instagram and Twitter, or email us at info@goodquestion.ae. Good Question is a production of the Youth Science Council and the Office of Advanced Sciences in the United Arab Emirates. Produced and directed by Hind Al Ali and Hayat Al Hassan. Sound design by Gareth Chen. Sarah Al Ali is our editor. Our social media and communications are managed by Mohammed Al Mansouri and Fatma Luta. And I'm Sarah Shirbaji.